Hey guys, I hope you're good. Just wanted to go out get after this problem. So when I made a mistake on in class, and just wanted to make sure you have a correct derivation somewhere. Um, the derivation I did was missing an important minus sign. Whilst the expression was correct, it it just wasn't algebraically clean at the end, and there are particular things I have to do in my equation to make my expression algebraically clean, and also with the correct minus sign that I was forgetting. But anyway, um, let's get started. So my system, the pulley is rotating and has a mass, so um, I can't assume that my tensions are different on the masses. So my goal is to find the acceleration of the system. Let's see, find A, right? That's my goal. My goal is to find A. So now, what I gotta do is step one, which would be analyze motion, or let's see, analyze forces on the masses. All right, we're gonna do this first to see if we can find what forces are acting on the masses and what the magnitude of those forces are. So the first step is to draw a free body diagram. Right, that's the first step. So it's my M2 here, and this is going to be, here I see I'm on a string, so I have a tension, T1, and here I'm falling down, so I got a weight. I want to call that weight 1. And then here, I have a tension again, T2 on the rope, and I have a weight 2. So now, in this question, one of the most important things to do is decide what direction is positive acceleration. The convention is normally to put the direction of positive acceleration in on the side it will move. So on the side the whole blocks will move if it's let go from rest. And this M1, since M1 is bigger than M2, this block is going to move downwards towards M1. On this side, my positive acceleration is down. But when this moves down, it's going to cause M2 to go up. So for this side, my positive acceleration is up. So now I need to make my dynamic equations at this stage now, so I can find out the sizes of the tension, of the tension forces acting on this. Okay, so I begin. What's in my f of x, f of y? F of y is going to be tension. Actually, let's be careful. I'm moving a bit too fast here. So M2 here, yeah? What's acting on it? We have our tension and our weight. In physics, the convention is that if we move counterclockwise, we're moving in a positive direction, right? So I'm saying counterclockwise, positive. So I can actually write my angular acceleration symbol there and say that if my angular acceleration is moving in a counterclockwise direction, it's positive. So now let's get started. So M2's tension be positive. I have ones here, apologies. Ones and 1. All right, M2's tension will be positive. It's going to be T2, and the weight will be negative, weight 2. Then the same here, it will be different. Here instead our weight will be positive, and our tension will be negative. All right, and that's all because of the direction of acceleration. So now I can plug in my Newton's second law. I have F equals ma. So this is going to be M2a equals T2 minus omega 2. And then this is going to be M1A, which is going to be M1G minus T1. Right? Right. So now I know the forces acting on my system is tension. So tension is what causes this to rotate. And clearly I won't have any information. But before I get there, I need to know the magnitude of my tensions, right? So if T2, look for T2 here, I know T2 is going to be equal to M2A minus plus M1G, right? Just solving for T2 algebraically, taking the weight, which is equal to mg, taking across the equal sign. Then T1 is going to be equal to M1G, it's supposed to be M2G, M1G minus M1A. Right? Yes. Because the T goes across, it becomes positive. The M1G stays there. And M1 goes across, it becomes negative. So that's M1A. All right? So I basically know the magnitude of force, which will be very, very important, of my force, which is tension. Okay. Sorry. I already kind of solved this earlier. Okay. So my step 2 now will be to get the dynamic equation of the pulley and solve for alpha. So if you remember, I said that my counterclockwise angular acceleration is positive. I'll put that there for reference right now. So now, this system here is what the pulley sees. All right, this is the system of the pulley. So imagine this case, the pulley. What the disc feels is the tension from the rope only. The disc only feels the tension of the rope. All right, T1 and T2. So that T1 and T2 was what I got from the previous dynamic equations. And I can use my torque, the torque of the system, to find values of my angular acceleration, which inherently will lead me to my tangential acceleration. But anyway, so T1 has a weight M1 on it. So I know the system is going to move counterclockwise because T1 is going to pull it in that direction. That's what we're moving counterclockwise. But that's important for a later step. So yeah, let's get more information on the system here. So step 2 will be get dynamic equation of the pulley and solve for alpha. All right, we get the dynamic equation of the pulley and solve for alpha. So from here now, all right, my Newton's second law, net torque is going to be equal to I alpha, and then from here, I see what torques are acting on my system. So my net torque will be T1. Is T1 positive or negative? It's negative, and that's mainly because it's causing the disc to go clockwise, and T2 is positive because the mass there will push the disc counterclockwise. So T2 will be positive. And so what's the magnitude of torque? We know that torque is going to be equal to RF, right? So if I write my equation, torque net is going to be equal to T minus T1 minus T1R plus T2R. Right? Right. So, and these are all the forces on my system. I can just write my equation kind of nicely. So T2 minus T1. Yeah, just rewriting my equation in a neat manner, not really changing the math. And then my torque net here is going to be I alpha, according to Newton's second law. I can solve for alpha and get that my alpha expression going to be R T2 minus T1 over I. All right. Then this can be simplified a bit further. Alpha is going to be R T2 minus T1 over M R squared. And alpha is going to be equal to, an R will cancel there. T2 minus T1 over 1/2 MR. All right. And this is where we were in class. Hold on. So I'm just going to copy and paste this. Yeah. I just copy this. All right. So now I'm going to step 3 of our solution. Use relationship of tangential and angular acceleration. All right, and that's just going to be always AT will be equal to alpha times R. Now this alpha, we have to think about the direction our pulley is rotating in. All right, and the direction it's rotating in is the the pulley is rotating in the clockwise direction. All right, but our convention, we've set it as alpha is moving in a counterclockwise direction positively. So because our system is moving in a clockwise direction, its angular acceleration is negative. If I divide by R on both sides, I get alpha is going to be they cancel out. I get alpha will be minus R. All right, yeah, multiply both sides by minus sign, that will become positive. And yes, so now I can plug in this A here. I say A over R going to be equal to T2 minus T1 over 1/2 MR. Can multiply both sides by R. Poop, 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 poop. A is going to be equal to T2 minus T1 over 1/2 over M. And this is MP, of course. All right. So now, from here, what we do is we need to plug in our T2 and T1 that we solved for earlier. All right, this is the penultimate step. Okay, so I'll just copy and paste. Oopsie. I kind of solved this a little bit earlier. Just scribbled a little bit. All right, penultimate step. Let's get that T1 and T2 as well. Just copying and pasting from previous chapter, page, sorry. So I'm going to say A is equal to M2A plus M2G, right? And then that's going to be minus M1G. On this A is minus, right? Minus sign, go to the minus sign there. Minus M1G. Well, with a minus sign there, so that's why it's going to be negated. Plus M1A. Right? Because you see this minus sign here? If I plug in T1, I have to negate everything there. All right, and it's all over 1/2 MP. All right, and we reached this stage in class. But to make our algebra cleaner, that's all we need to do is cross multiply first. Cross multiply, and it's going to be minus 1/2 MPA, right? Equals M2A plus M2G minus M1G plus M1A. All right, this is good. And then from there, what we do is group like terms. So minus 1/2 MPA is going to be equal to M2A minus plus, just grouping my like terms, M1A, and this is going to be plus M2G minus M1G. All right, we're getting there. I take all my like terms across. I want all my A's on one side. So MPA minus M2A minus M1A is going to be equal to M2G minus M1G. All right? And then from there, I'm kind of in business. I can factor out an A minus A. And then I'll say it's going to be 1/2 MP plus M2 plus M1. It's going to be equal to M2 minus M1G. All right? And I can divide both sides by 1/2 MP plus M2 plus M1. It'll be equal to 1/2 MP plus M2 plus M1. So it cancels out. I can actually multiply it by minus that to get rid of the minus sign, you know. And then I get that my positive A, all right, is going to be equal to M2 minus M1, all right, G is going to be over, all right, it's going to be over, I'm going to take the minus sign, this minus sign up here, right? Because I can. Because this is multiplied by, I hear that brackets here, by the way. So it's going to be over 1/2 MP plus M2 plus M1. So now this minus sign, I can distribute it inside, and this becomes it becomes M1 minus M2 G. All right, let me just write it for you. Oops. Just write it for you concretely. A is going to be equal to M1 minus M2 G over 1/2 MP plus M1 plus M2. And there's your derivation. We finally have it in a correct manner. I know we did this a bit earlier, this Mr. Bailey, but even then, we both made a mistake. But it kind of irked me because we didn't have a correct derivation of this at all somewhere, and I felt we just needed that. So now it's just annoying and tedious. But if you found yourself have doing these comfortably, I'd say you're in a good place with your physical intuition. If you don't, I would just say keep trying. And yeah, um, good luck, guys. I hope you enjoyed this video.